Okay, so we have one diode across which I'm plotting some transfer functions and clipping for some circuits. Okay, so that you should become comfortable with these circuits. Okay, now this is a circuit, okay, where we're applying a voltage source Vs, and this is behaving like an ideal diode, and I have R here. Okay, now, now I want to plot the transfer function of this graph. Okay, that is, I want to plot how V output changes when we vary the V input. So can you tell me what will happen now? Okay, so you can see this diode is reverse bias by a voltage VB. Okay, so until you don't apply, until this source, okay, doesn't become greater than this VB, okay, the current will not conduct. So this Vs has to be greater than VB. So until this Vs is less than VB, okay, until Vs is less than VB, what will happen? You have this diode is open. Okay, so you have zero current in the circuit. This circuit is open. Okay, so when Vs is less than VB, what will happen? You have this plus minus Vs. Okay, this diode is open because this is reverse bias, and you have this kind of thing in the circuit. So you have this kind of circuit. Okay, so that means what? This is out of the picture. The source is out of the picture now. So you have only this VB connected here. Okay, and also there is a no current. The circuit is incomplete, so current not flowing here, current is not flowing here. So whatever source is there, okay, whatever voltage is there, okay, that will be same. This is like a wire. Okay, so you get only voltage up to V output will be your VB. Okay, until your V input is VB. Okay, and doubt about this question? Now, once your Vs become greater than VB, once your Vs become greater than VB, I am talking about is positive cycle, okay, or negative cycle. This is for positive cycle only, positive Vs values. Once Vs become greater than VB, then what happens? This circuit become your short circuit. Okay, once your Vs is greater than VB, this diode conduct and become short circuit. Okay, so now once become short circuit, so whatever voltage is here, this point and this point, they are same. That means now you got, okay, Vs equals to V output equals to Vs. Okay, earlier what was there? Earlier you just have when Vs was less than VB. Okay, in that time you have V output only equals to VB. Now once Vs is greater than VB, you have V not equals to Vs, because now there is no circuit, so this voltage will be equal to this voltage. So above Vs, you get this kind of slope. Okay, now what happens when we go in negative side? Okay, when we apply reverse bias, so when we apply negative Vs, okay, negative Vs, that is plus is there, minus is here. Okay, in that case what happens? So when you have negative here, okay, this is the voltage. So when you apply negative, this already reverse bias, and now you're making it more again reverse bias, isn't it? What will happen? So this battery is there, okay, this is there, so this diode will become reverse bias. So what I'm expecting, if it is become reverse bias, or for this particular question, leave it. Okay, I am not plotting this negative cycle. What should become a negative cycle? Negative cycle, I think this if it is a open circuit, so this is not in picture. Okay, so always get you like this only, you get same VB. Okay, isn't it? How much you'll get? You get same VB. Now here, if I measure here voltage here, again should come VB.
The
So
resistance effect will not come.
huh?
Resistance effect will come, na, something. It may be maybe less than maybe.
So current is not there, na? So current is not there. That means a voltage drop is not there. Okay. So I'm
नेगेटिव एंड पॉजिटिव कैसे लिया हमने
नहीं
दैट
वो हमने अगर हम इसको नेगेटिव वोल्टेज लगा रहे हैं तो वो तो रिवर्स बायस ही है बट आई एम मेजरिंग वी आउटपुट लाइक दिस. Okay, so V output I'm getting all VB positive VB only. So even though you are negative voltage, you're getting positive VB only. Okay, because here is like same thing. Here also you have a reverse bias only. So this was open. So this is here also same thing. This is reverse bias. This should be continue. No? Then no nothing difference between this and this. Okay, here also it was a open circuit only because VB was less than VS was less than VB. Okay. So let me give a couple of more examples. Okay. I'm applying VS here. Diode is ideal. Okay. Can you plot this one? V naught versus V input. Okay. So this is battery VB. So what should I expect? Okay. Again, if VS is less than VB, then this diode is open circuit, reverse bias, open circuit, so no current flows. So whatever voltage is there, that will voltage come here. Are you getting my point? If VS is less than VB, okay, that condition you V output, what I'm measuring here, that will be equals to VS because this will become open. So once this is open, okay, no current is flowing here. So I'm simply measuring what this voltage here. So V naught will be your equals to VS. So you can plot V naught equals to VS. Okay. Once it's above greater than VB, then this diode becomes short circuit. Okay. When VS is greater than VB, it becomes short circuit. Now current is flowing. Now the voltage across this 2 point is what? VB. So this becomes constant. Okay. Now come to this was a positive VS. Now if I say negative VS, again this diode will become open. Okay, if diode become open, that is like same first case for negative VS, your V naught is always equals to minus VS because now you have voltage source, you have voltage here. So you have same thing. So you have voltage negative here, positive here. So V naught equal to minus VS. This will continue. Clear?
Sir,
Imagine
V naught equal to minus Vs. It is in Vs greater than Vb.
Vs is greater than Vb. Okay. Then this circuit is open because the reverse bias. Because now negative. Now you have a negative, na? This diode become reverse bias. Okay. You are asking this one, na? Oh, yeah, this will be short circuit. This will be short circuit, na? Positive circuit VS short circuit. So what V naught equals to what? Simply this voltage, this short circuit. So you're measuring this one only. So V naught equal to VB. Is it clear?
पॉजिटिव हाफ साइकिल में ये शॉर्ट सर्किट हो जाएगा ना, तो वी नॉट वीबी कैसे आएगा का?
अगर शॉर्ट सर्किट हो गया तो ये वोल्टेज तो यहीं पे आएगा. सेम वोल्टेज सेम ना. Somebody mic is on. Okay. Now you have a diode. Now this is silicon diode. Okay, 0.7. And here you have a silicon diode again. Okay. I want to measure V naught here. So now you people tell me what kind of graph I'll get. I have V naught, V input. Okay. Tell me how it come graph will come if I apply VS. So when I'm applying VS here, this diode is always reversed by a positive cycle. है कि नहीं है?
Yes, yes, sir.
So this is open. This is always open. इसका कोई issue नहीं है. And this is also open until VS is less than 0.7. Okay. So up to 0.7 voltage, this become conducting only when we apply VS become greater than 0.7. So until VS is less than 0.7, okay, this whole circuit is open. So you get whatever is coming here, you get here. Okay, so you get like this. Once VS is greater than 0.7, okay, this diode becomes short circuit. Okay, this diode become short conducting. Okay, so now how much voltage I should get?
0.7 constant.
0.7 actually 0. I should get 0 if it is ideal, but this is not ideal. Now this is 0.7 volt battery, so I get this become fixed, so I got constant 0.7. Good. Okay, now similarly in reverse cycle, this was positive, reverse cycle this minus. So now this diode, okay, this diode will become your positive, and this will be always in reverse bias. This will be always in reverse bias. Okay, and this will become when you go up to 0.7. Okay, this is open. After once this become greater than 0.7, then again this become constant. This become battery, and you get constant voltage here. Okay, here. So same thing when I does it on for sine wave, like I have a sine wave. Okay, V input. Now if I plot V output, okay, if I plot V output, what will become? Up to 0.7 you get as it is, and after 0.7 this become constant, and before he constant here same thing, and this become constant to 0.7. Okay, again here, so this is your 0.7, and this is also 0.7. Okay, so this part is clipped. This part is clipped. Okay, so this is your first sine wave. Okay, clear? Any doubt? Okay,
सर
so no
अगर
doubt.
हम दो डायोड लगा दे सेम ही डायरेक्शन में, मतलब एक सिलिकॉन और एक जर्मेनियम लगा दिया,
हाँ,
और अगर
तो फिर तब तो 0.3 आएगा।
तो
जो पहले कनेक्ट हो जाएगा वो आ जाएगा वोल्टेज।
ठीक है सर।
नो फॉर एग्जांपल एक क्वेश्चन, 2-3 क्वेश्चन आ रहे हैं। You're applying V input, okay, and then you're applying here a diode here plus minus, This is your 1 volt. This is your 2 volt. Okay, I'm measuring here V output. Now I want to find a range of, okay, now first let me this question came in gate. Okay, so before I tell you the question, exit questions, you need to tell me how its transfer function looks like. They both are 0.7. 0.7. Okay, tell me. So in question says find the range of V input for which V output is equals to V input. Okay. Now you have to look again, same thing. You have to first apply positive voltage. Okay. So when you are applying, say positive voltage, what happens when you apply positive voltage here? This diode is already reverse bias. You are making it more reverse bias, so this will become open. Okay. This diode is reverse bias. Okay. So already reverse bias, you making positive cycle, you're trying to make it forward bias,
Forward
but
bias.
it requires 2.7 volts. So until 2.7 volt, it is open, isn't it?
Yes.
Are you getting my point?
Yeah.
So up to 2.7 volt. Okay, to make this diode conducting, you have to apply at least 2.7 volt. Okay, so once you apply 2.7 volt, this also open. So your V input is coming as it is up to 2.7 volt. Okay, once this become conducting, then this become battery, and you get the voltage equals to this become constant, positive cycle 2.7 volt. Okay, same thing happen for this negative cycle. When you make this here positive, here negative, you're making here positive, here negative. Now you're trying to make this diode as a forward bias, but this is the barrier. Okay, this you need to overcome this potential 1 volt, and then you have to apply 0.7 here. Okay, so you need to apply in reverse bias, you need to apply at least 1.7. Okay, so up to 1.7. Okay, up to 1.7 value, they will be same, and after that this become constant up to 1.7 volt. Okay, so you say find a range of V input for which V output is equals to V input. Okay, that means
Sir.
V input ranges is minus 1.7 volt to 2.7 volt. So when V input is in this range, you're getting exactly V output equals to V input. Yes.
Sir, that polarity of 1 volt is different now. So is
Uh, so,
this
so, so the polarity is 1 volt is different because we want to make it reverse bias, no? So here I'm when I'm positive cycle, my positive is coming here, and this is against the positive. Okay.
yes.
Similarly, here I'm coming here, and this positive is against this positive. Both the same. Both are trying to make it is reverse bias. Okay.
Sir,
Yes.
how will you say, sir, minus 1.7?
What did you say? So now this diode is reversed by 1 volt. Okay, isn't it? This is positive plate, this is negative. So this negative, this is negative 1 volt. Okay, here. So if I want to make this suppose this current is source is giving current. Now I want to reverse this current. Okay, so what I should do? I have to overcome this source. So I need V input equal to 1 volt, and then in order to make this positive, okay, a battery, again I need 0.7 volt. So total I need now how much? I need 0.7. So now this is a V input I'm measuring, and I'm getting opposite. I'm getting this 1.7 volt like this, total 1.7. So that is V output is negative. That's why I'm plotting V output is negative. Okay. So you can see now. Okay. So once 1.7 volt is there, this becomes fixed. This is already open. This is already open for reverse bias, na? That you want to understand. For reverse bias, this is already open. Because this source, this is a 2 volt. So this is already open. Diode is open, means this is not in circuit. This is open circuit. Only now this is in circuit. Similarly, for positive cycle, this is open, and this becomes in circuit when you make voltage greater than 2.7. If not clear, please tell me clearly. So I should explain
So
again.
first branch is not clear only.
Which
Second
one?
one 1 volt और 0.7 वोल्ट है ना, मतलब मेरा कंफ्यूजन इसमें हो रहा है कि उनके जो पोलैरिटीज है ना वो रख के सब्सट्रैक्शन ऐसा
हाँ तो पहले केस में इस केस में क्या अंतर है? खाली डायोड यहाँ से डायोड यहाँ बैटरी पे ले जाता है, वहां से डायोड पहले आता है, उससे क्या फर्क पड़ता है?
केस नहीं सर, मतलब इस ब्रांच में जब करंट फ्लो हो रहा है ना, पहली
हाँ
जो ब्रांच है, हाँ
हाँ
वो समझ में नहीं है।
हाँ तो करंट तो अब तो करंट ऐसे फ्लो होगा ना, इफ इज ग्रेटर देन 1.7 वोल्ट दिस वोल्टेज, so this become battery now. Now current will now this source is here there's no current. Now this source is bigger na compared to this one 1 volt.
Yes,
So now this will dominate na.
yes.
So when second one we are taking that second case वाला जो 2 वोल्ट 2.7 वोल्ट वाला जब लेते हैं हम
वो
कंडक्टिंग में,
पॉजिटिव साइकिल के लिए।
हाँ जी पॉजिटिव साइकिल के लिए कंडक्टिंग में लेते तो वी हैव टेकन द कांस्टेंट वोल्टेज 2.7, तो हम जो
हाँ।
आर के अक्रॉस जो ड्रॉप है उसको नहीं अच्छा ओके ओके फिक्स हो गया, ओके ओके सर सॉरी सॉरी यस यस
वो फिक्स हो गया, बाकी बचा हुआ रेजिस्टेंस पे आ जाएगा। गेटिंग वी इनपुट यू हैव समथिंग fixed and remaining you have one resistance. Now one more last question of this clip. Okay, now I will not do, you people have to tell me what is diode is ideal. Okay, this is V input, okay. Now you tell me what is the situation, and this resistance is also 10 kilo ohm. Okay, so first I am calculating for when my input is positive. Okay, for positive V input, what is the situation?
the battery voltage is given
What battery, which one? This is given 5 and 5 volt and 5 volt. Okay, now tell me what will happen.
पहला डायोड तो ओपन रहेगा।
So when I have positive cycle, this is already reverse bias, this again be reverse bias, so positive cycle, this both are reverse bias. Okay, now this will also reverse bias until
5
0.
वोल्ट।
okay, until your V input is less than 5, that is open. Okay, so that means this is also open, so up to 5 volt. Okay, so you got V input equals to V input. Okay, until you have Vi is less than 5. Okay, for positive vi. Similarly, we can say you get same v not equals to vi when you have -5. Can I write like this?
Yes, sir.
Okay, the same thing for negative cycle also. For negative cycle also, this diode is always open, and this will connect only when this voltage become -5. So this v not equals to -5. So when v so in this range, this same. Okay, now I am again coming back to the positive cycle. Okay, when my vi is positive cycle, positive for positive. Okay, v input, when v input is greater than 5 volts, what happens? Okay, so when v input is greater than 5 volts, okay, again we have to check this diode become start conducting, and I this becomes short circuit. Okay, sorry, this is open, this diode becoming start conducting, this becomes short circuit. Okay, when positive vi comes. So now for this positive vi, I need to calculate how much voltage is there. Okay, so you can see v naught is simply equals to this time is plus 5 volt. Okay, plus current, say id into 10 kilo ohm. Is it correct? Okay, now what is id? I don't know, so I need to first calculate id. Okay, so when I have a vi greater than 5 volt, okay, in that case I can take this loop and I can write the equation. So I have first cycle, this is a plus, this is a minus. Okay, so I can write minus vi. Okay, this 10, this 10, 20. Okay, say current is flowing id. Okay, then I have id into 20 kilo ohm. Okay, and then this full is v naught, and this full is v naught equals to 0. Okay, isn't it? Or what should I write? And I'm
20
writing
किलो ओम कैसे लिखूं? ऊपर वाला
this
रेजिस्टेंस
10 kilo ohm. Okay, and then you have to write this 5 volt. Okay, 5 volt battery equals to 0. Now you can tell me what is the id. So my id will be, okay, this vi go there, so vi minus 5, okay, divide by 20 into 10 raised to power 3. This is my id. Okay, so I know the id value in terms of v input. V input can be anything, 5, both is 5, 6, 7. Okay, anything can be. So I can put the value of id here, so I can get my equation for v naught when vi is greater than 5 volts. So I get 5 plus id is vi minus 5. Okay, 20 into 10 raised to power 3. Above there is a 10 into 10 raised to power 3. This cancel, cancel. Okay, so what I get vi by 2 minus 2.5 and plus to 5, so plus 2.5. Okay, so this is my equation for v naught. Okay, when my v input is greater than 5 volt. Please tell me if you don't understand. Is it clear what I'm doing? So now similarly you can do it for negative cycle when vi is less than, when we have already written v input is v not equal to v input, whether it is a positive or negative. When we have v input is less, the limit between 5 volt to minus 5 volt. Okay, now second cycle. Okay, so this is clear. Parampreet, Kanchan, Radhika, clear?
Yes, sir.
Yes, so it is clear.
Okay. Now second case, when my vi is less than vi is less than 5 volt minus 5 volt, matlab in terms is greater negative side. So this case this will become positive, okay, and this diode will become conducting, this diode becomes short, this diode becomes short, okay, and I am in negative cycle. Negative cycle means I am here minus plus here, okay. Now this is open, so of course I need to consider this loop. So current will be flowing like this now, okay. So again I need to calculate, I can apply this loop. I can say right minus vi, okay, plus 20 kilo ohm into id, okay, and this time positive minus, so this plus 5 volt again, okay, equals to 0. So I get id equals to how much? I get id equals to again vi minus 5 upon 20 into 10 raised to power 3. Now what is the equation for v dot this time? I am measuring v dot like this, and this current is going here, so voltage drop is like this, okay, voltage drop is opposite. So now my v naught this time is equals to minus, okay, id r, okay, plus 5, okay, that is id into r is 10 kilo ohm, 10 raised to power 10 into 10 raised to power 3 or 10 raised to power 4, okay, id plus 5 is the voltage. You can put the value of id here, so minus id is my vi minus 5, okay, 20 into 10 raised to power 3 into 10 raised to power 4, same thing, plus 5, okay. Now minus, okay, you get again cancel, okay, so you get
vi by 2
vi by 2 minus
plus
2.5
2.5.
plus 2.5, okay, you got same equation with now negative sign. So this is the equation for v naught when you vi is less than minus 5 volt, okay. But you have to remember this thing, in this, by deriving these things I have already considered the polarities. I already taken this vi negative. So now whenever you use this equation, you have to pull positive v input only, because the sign I have already taken care, okay. I either you can take first equation and then just reverse the sign when using for negative cycle. V input sign you reverse, okay, plus a second cycle. So both are same. Actually, both thing will give you same thing. In previous question, what I got in previous question, what is the here minus was plus was there? Positive
plus
cycle
plus only.
plus था, अभी plus है ना? But now this has sign minus sign came here. Okay, let me check answer. Okay, it looks correct. Just look it once more. Now this is minus vi, this is plus, okay. So now this voltage plus and this voltage plus. So my v naught is like this. So this should be v naught minus idr plus 5. It's correct only, okay. And id value is here, same thing, okay, correct. So I'm erasing this one, okay. So this was just a clipping, okay. I was trying to show you clipping using transfer function, okay. So once you know the transfer function of the circuit, then it becomes very easy for you for any given input. Now if you know the transfer function, if they give you sine wave, easily you can draw for sine wave or any triangular wave, okay. So you can easily draw for any kind of, whether it is a square pulse or anything, okay. You can draw very easily this clipping circuits, clipping clamping, okay. Now next is a clamper, okay, clampers. Now on clipping, we were distorting the signal. We are some portion we were clipping. Okay. Now clampers, we do not distort a sample. Okay. Clamper is simply shifting of level, shifting of, okay, level of input. Okay, shifting or level of signal. You have any signal, you want to just shift their level up and down, there will be no distortion. Okay, and the clapping circuit always accompany a capacitor. Okay, so there will be always a capacitor in the circuit. You have a diode in the circuit. Okay, this is C, and here you have a R resistance in the circuit. This is, you have V naught. Okay, now how does clamping work? Okay, and what is the condition of clamping? The first thing is, condition of clamping is that you have a source which is input. Okay, sine wave, any signal which has some time period. Okay, and this is a capacitor. Then the discharging time of capacitor, okay, discharging time of capacitor should be greater than your time period. Okay, so the condition for clamping is the RC. Okay, RC for this RC value, time constant value of this capacitor should be greater than your time period of signal. Okay, T is a time period of signal. Okay, so now what happens when RC is very high? Okay, so when RC is greater than T, your discharging time of capacitor is greater. Discharging time, okay, of a capacitor is generally 5 RC. Okay, almost equal to 5 RC. Okay, so obviously 5 RC becomes greater than the time. That means the time period of the signal is less compared to the discharging time of the capacitor. Okay, so what I'm trying to say, once you charge the capacitor, it will not discharge. Okay, for example, now this input I'm applying here. Okay, this is a peak value Vp. So now this capacitor will charge. Okay, capacitor will charge and current will flow here, and your diode will conduct, isn't it? So now suppose you have a input. Okay, you have a V input. Now positive cycle for this V input, your diode is forward bias. Okay, so once diode become forward bias, what happens? It becomes short circuit if it's ideal. If it's some 0.6, then you apply 0.7. Now Vs will increase and this capacitor will charge, and this capacitor will charge up to T/4 time. Okay, so this capacitor will charge up to what? Up to the peak value of this, source. Okay, so here I'm showing that capacitor charge or current flows up to T4. The current flows in the circuit for T/4 time of the signal. Okay, are you getting? Up to here only you get the current flow. Okay, later what happens when you come, when your input decreases?
Sir, so why it is T/4 only?
So you already it get charged up to peak value, na?
Yes, sir.
Already it will charge up to peak value. Now once you charge up to peak value, your input is decreasing. This is decreasing, but this is fixed.
Yes, sir.
This is fixed.
Yes, sir.
Okay, and this fixed. So this is negative volt. That now it's behaving like a battery. Okay, it's behaving like a battery. So it makes this capacitor as a reverse bias, and this capacitor becomes open. Okay. Now what happens again? Actually it takes 3 to 4 cycles to charge. Okay, but for explaining the thing, we say in first cycle itself will charge. Okay, so whenever we draw the clamping signal, we assume everything happened, the capacitor already charged, and for next cycle we are doing clamping. Okay, So for if you cycles already it is charged, and now we are doing clamping for the next signal. Okay, now this capacitor already charged. Once this is charged, now this voltage is higher than this voltage always. And only when this become P in a VP, then only the same. Otherwise, this voltage is always same. Now suppose my second cycle comes. Okay, second
Sir?
cycle.
Sir, when it will have peak voltage, then it will it will make able the diode to
Diode
conduct.
diode. Now after that, after it will make open. Earlier it can charge only when diode is conducting. Are you getting? This capacitor can charge only when diode is conducting. So initially for up to T/4 time, this time, okay, when VP is getting this circuit is getting charged, and this is short circuit. Short circuit, that's why current is flowing. That's why it's getting charged. Okay, once it's charged fully, okay, this diode makes this capacitor makes this diode to permanently open. Why? Because
Okay,
for
sir.
positive, so this is already open. Okay, and negative cycle, this is already open. Are you getting? When this voltage become negative, reverse cycle, this is already open. So now not so it will not reverse it will charge, it will not charge get charged reversely charged. Okay, so now once this voltage is fixed, okay, this will maintain. Why? Now suppose you have removed one cycle. Now next cycle again it will get charged. Next cycle again this voltage, if this is greater than VP, okay, so again this voltage will voltage maintain. It will not be decreased. Okay, because the discharging time of this capacitor is very high. Are you getting? The discharging time of this capacitor is very high. So even though you are applying some cycles, 4 or 5 cycles, okay, it will not get decreased. It will maintain. And once it will try to decrease, suppose it has decreased. Suppose I am applying here. Now I am plotting V naught.
Sir, for the next 2-3 cycles, it means that the diode will be open.
Diode is open.
Because-
Okay. Diode is open. Okay.
For the
Diode is
next-
now suppose this voltage. Suppose I am plotting here. This is my capacitor. Okay. Now capacitor voltage suppose coming down slightly coming down. Then this become higher than this voltage, isn't it? For peak value. So
Yes.
this will again this diode will again charge this capacitor. This will conduct. Okay, so for you can assume that your diode is voltage slightly will decrease. Okay, but as it slightly decreases, again this source will charge it, because this VS become VP will become greater than this one. When this is slightly less than VP, this become positive. Again, this diode makes positive forward bias, and you get always this VP is maintained, because this is like working as a battery. Okay, so this making this diode as हाँ बोलिए.
मतलब सर पॉजिटिव और नेगेटिव साइकिल दोनों के लिए हमें वीपी कांस्टेंट लेना पड़ेगा, मतलब
Yes.
कैपेसिटर.
Diode, you should assume diode is always open, and this voltage is maintained. But about
So
suppose
diode is open only in negative cycle, na?
four cycle, बाबा यहाँ बैटरी की भी तो बैटरी लगा हुआ है. This is also battery. This making it reverse bias, and negative already making reverse bias. So now this is always open. Now this will only conduct when this decreases. Once this decreases less than VP, then this source will again charge it. So you practical purpose, you assume, because we are assuming discharging time is very high compared to the signal of the time period of the signal, this voltage is always across this capacitance is always VP. So this will always maintain. Now I need to calculate my V output. Okay, what is my V output? Okay, so now V output will be what? If I write the equation here, so my equation is like Vs, okay, then plus Vp, and this plus V naught, okay, equals to 0. Now my V naught will be always equals to Vs minus Vp. Okay, now let me plot my V output. Okay, when my V input is 0, this is Vs, V source. Okay, V source is 0, then my V output is V peak, okay, and why when my V source is VP, then my V output is 0, okay. So I'll get this kind of equation, this kind of curve. Again here 0, okay. Again when it is minus VP, Vs is minus VP, V0 become minus 2 VP, okay. So for here this goes like this, okay, minus 2 BP. Again it comes here for Vs, and when this becomes positive it becomes here, okay. So are you getting what is happening? So this is basically is get shifted, okay, by VP. Now this signal goes down here, this becomes here, this becomes here, okay, this goes down here. So this is your minus VP and this is your minus 2 VP, okay. So this is basically working of clamping, okay. So you can ask me any question. Clamping means shifting of signal up and down, okay. So this capacitor, okay, or this circuit has shifted this signal by, okay, minus VP. So this is
सर
like,
ये -2 VP कैसा है सर, एक बार फिर से.
Sir,
तो VS की वैल्यू तो चेंज हो रहा है ना, this VS is changing, VS is 0, you put 0, your V0 is minus VP. When VS is VP, you have V0 0, okay. When VS is minus VP, minus VP, minus VP, V0 is minus 2 VP.
Oh, okay sir, okay sir.
Sir,
Okay.
in clamping, it means whether we are applying this positive voltage, we are getting the negative always in the output.
Negative voltage, that means it's a clamping only, shifting of signal, okay. So there is a
Okay.
various kind of shifting, okay. This is the negative clipping, okay. You made a signal to move downward. There's a clamping,
Downward.
it's like you can this clamping you can make upward also. So we see tomorrow,
Okay,
okay.
sir.
Some more circuits here, okay.
Okay.
So I'm stopping here. If you have any question, please ask.
sir, it means in a clamping we use such a capacitor only for which RC is always greater than
Yes,
time
yes,
period of 10 to 6.
yes. Capacitor should not discharge, okay. Then only it works, okay. Otherwise this clamping, otherwise clamping will be not be perfect.
Okay, sir.
Thank you, sir.
Thank you.
Thanks, sir.